Hello guys, welcome back again to my YouTube channel. We have this beautiful uh, radical equations to solve. So we have two of them, they are simultaneous. We have two of them. Square root of p plus q over 2 plus square root of p minus q over 3 equal to 14. And then we have the second equation to be square root of p plus q over 8 minus square root of p minus q over 12 equal to 3. How do we solve this sort of problem? We are going to be applying some basic rules of algebra, okay, to solving this problem. So, if you are here and you are ready, I'm also ready. Thank you, and let's go. So we have solution. So I bring down the... Now, before we go ahead, you will see that you will notice there's a pattern. And the pattern is that if you look at this second equation, the denominator here is 8, which is actually a multiple of 2. Meaning that I can express this 8 as a product of a number and 2. In fact, I can, this 8 is a product of 4 and 2. Same thing here. This 12 is the product of 4 and 3. So we are going to start from the second equation. Okay, so we have p plus q, that's square root of p plus q over 8 minus square root of p minus q over 12 equal to 3. So what I'm going to do is to rewrite the expression under the square root, which will give me p plus q over 2, 4 multiplied by 2 minus, okay, p minus q over 4 multiplied by 3 equal to 3. So what I'm going to do now is to separate this so that I'm going to have, I'll split this up. So I'm going to have square root of p plus q. Okay, this is how I split it up. So this 4, you know, it's at the denominator, so I'm going to write it as 1 over 4 dot p plus q over 2 minus square root of, I do the same thing to this, so I'm going to write this as 1 over 4 dot p minus q all over 3 equal to 3. Now I want you to note that, or recall that, if I have square root of ab, this is the same thing as square root of a dot square root of b. Square root of ab will give me square root of a dot square root of b. This is one of the rules of radical, of simplification of radicals. So this equation now becomes square root of 1 over 4 dot square root of p plus q over 2 minus square root of 1 over 4 dot square root of p minus q over 3 equal to 3. So this will give 1 over 2 dot square root of p minus q over 2, the minus 1 over 2 dot square root of p minus q over 3 equal to 3. So you can see clearly the pattern here. So now I've expressed the second equation in the form, in a way that it looks similar to what we have here. So what we're going to do now is to say let m equal to square root of p minus q over 2 and n to be equal to p minus q over 3. So if that is the case, we can say the equations now, the whole of the equation becomes, so I'm going to, let me come over to this this side of the board. So what I'm going to do now is I'm going to rewrite this equation in terms of m and n. So this now will become m plus n equal to 14. I call this equation 1. And then I'm going to have the second equation will now be half m plus minus half n equal to 3. So from equation 2 now, okay, I think I need to rewrite this. So this will be half n equal to 3. So let's rewrite this. Since we have denominators of 2, so I multiply everything by 2. 2 times half m minus 2 times half n equal to 2 times 3. So that this gives me m minus n equal to 6. So I call this equation 2. I call that equation 2. So now from equation 1 and 2, I'm going to come over here and rub up all of this. So from equation 1 and 2, from equations 1 and 2, we have m plus n equal to 14 and then m minus n equal to 6. So I'm going to use elimination method by first adding up. So once I add up, I have 2m equal to 20. So m will give me 20 over 2. So that means that m equal to 10. So having obtained the value of m, I can quickly now obtain the value of n. So since m plus n is 14, so I can say that 10 plus n equal to 14. So n will be equal to 14 minus 10. So n is 4. So we have that m equal to 10 and n equal to 4. But don't forget that what we have is P and Q. What we have is P and Q. So I'm going to come back to this side of the board. Now don't forget we have said that M should represent P plus Q over 2 and N will represent P minus Q over 3. So I'm going to clean all of this. We have agreed previously that M should be equal to P plus Q over square root of P plus Q over 2, and N should be square root of P minus Q over 3. So now that we have M to be equal to 10, so I have M equal to 10. 10 will be equal to P plus Q over 2, the square root of it. So what I'm going to do now is to take the square of both sides. So once I take the square of both sides, this gives me 100, and then square and square root will go away, so I have P plus Q over 2. So from here now, I have here this will give me P plus Q equal to 200. That's another equation. I can call this equation 3. Now, from n equal to 4. So from this I have n equal to square root of P minus Q all over 3. But n equal to 4. So I have 4 equal to square root of P minus Q over 3. So this will give me, if I square both sides as before, so this will give me 16, and while this will give me P minus Q over 3, which will give me, which implies that P minus Q will be equal to 48. I'll call this equation 4. Now from equation 3 and 4, we can find the value of P and Q conveniently. From equations 3 and 4. From equations 3 and 204, we have P plus Q equal to 200, and then P minus Q equal to 48. So applying elimination method of solving simultaneous equations, we will get 2P equal to 248. That will give me P, if I divide both sides by 2, I will have P to be 124. Now that we know the value of P, we can easily find the value of Q. So from P plus Q equal to 200, and then P is 124 plus Q equal to 200. So Q will simply give us 200 minus 124, and that will be 76. So on the whole, we have it that Q will be equal to 200 and, P equals to 124, and Q equals to 76. So this is the solution, guys. Watch, learn, subscribe. Please, I want your comments. Please correct me, and in your comments, try to correct me. Point out areas that I need to improve upon, and then we'll be the better for it. Thank you. Share my video, like, and subscribe. I will see you next time around.